Hey guys, this is our brand new unit, section 1, part 1 of polygons. Okay, and we're going to spend this unit learning about quadrilaterals, but specifically we're going to talk about polygons today. Okay, so polygons, to be a polygon, you have to be an any-sided shape. It could be any number of sides, but the only two rules is that it can't be curved and it has to attach at the end. Okay, so let's look at a few different polygons here and see which ones are polygons and which ones aren't. Okay, so this one up top here, okay, you have a bunch of different sides. It's not curved, and it attaches at the end. So this, in fact, is a polygon. Okay, what about that moon next to it? Well, it curves. Okay, we can't have a curve, so this is not a polygon. Okay, this next one next to it, it doesn't curve and it is attached at the end, so this is a polygon. This one, it doesn't attach, so it is not a polygon. And let's keep going on down the row. This one works. This guy curves, he's not a polygon. This guy works. And lastly, our circle, of course, he does not work. Okay, so these are just a few examples of polygons and how to identify if something is a polygon or not. Okay, so just a few terms for us to look at. I need you to go ahead and define the side of a polygon. Okay, so the definition of a side of a polygon, excuse my handwriting here, the side of a polygon, each segment that forms a polygon. Okay, so side of polygon, each segment that forms a polygon, and you'll notice over here on your polygon, the side is just any side of it, any segment that forms the polygon. Easy as that. Okay, vertex of a polygon. Okay, the vertex of a polygon is the common endpoint, so common endpoint, the common endpoint of two sides. Okay, so the common endpoint of two sides. So you'll notice over here, a vertex would just be the endpoint of two sides. So where they intersect, that's going to be called the vertex. Okay, last term you need to know is a diagonal. And a diagonal is a segment that connects two non-consecutive vertices. Let's move over a little bit. Vertices. Okay, so connects two non-consecutive vertices. Okay, so if you look over here, your diagonal, this guy, he connects vertices, which is B and D, but they are not in a row. They're non-consecutive. Okay, so these are the three terms that I want you to be aware of today. Side of a polygon, vertex of the polygon, and diagonal. Okay, so the next terms that you need to know are the names of the polygons for different sides. Okay, so I'm going to go ahead and write all these down at once, and you're going to have to pause the video and then write them down. All right, so I have all of the different polygons labeled by side here. Okay, a three-sided shape would be a triangle, 4 is quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 is nonagon, 10 decagon, 12 dodecagon, and n is called an n-gon. Okay, so go ahead and take a second, pause the video, and write all these down, and then we will continue on. All right. Okay, now we're going to tell whether the figure is a polygon, and if it is a polygon, name it by the number of sides. Okay, so this first one, we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 sides. Okay, it is 6-sided. Okay, so if it's 6 sides, what type of polygon is it? Well, that's going to be a hexagon. Okay, the next one, okay, we got a 1, 2, 3, 4, 5-sided shape. Or 1, 2, 3, 4, 5, 6, 7-sided shape, excuse me. 7 sides. And a 7-sided shape would be a heptagon. Okay, so this is pretty easy. Just got to count and look at your chart and see what one it fits. Okay, this one is a curved line, so this is not, it is not a polygon. You cannot have a curve in a polygon. All right, I would like you to try, you try 1A, you try 1B, and you try 1C. Count the sides and decide if it is a polygon. Okay, the next section is called, what is a regular polygon? Okay, so a polygon is concave. Okay, it's concave if any part of the diagonal contains points in the exterior of the polygon. Okay, if no diagonal contains points in the exterior, then the point or the polygon is convex. Okay, so you see some pictures down here. A concave quadrilateral, obviously it kind of caves in. Okay, so it kind of caves in. So you know when it caves in that it's called a concave polygon. Now a convex quadrilateral would look like this one right here. A concave shape is just not going to have any part that caves in. Okay, so you'll notice this guy, okay, they're fairly normal looking shapes. They don't have any part that caves in, so that's going to be a convex type of polygon. Okay, I also need you to understand the term regular polygon. A regular polygon is a shape that has not only 4 sides that are congruent, like this shape up here, but it also must have angles that are the same. Okay, so a regular polygon would look something like this. Okay, you could have a square that has all 4 angles the same, or all 4 sides the same, and all 4 angles the same. Okay, so be aware that that is the definition of a regular polygon. Okay, so let's look at a few examples of the terms we've been talking about. And we want to decide if the polygon is regular or irregular, and then tell whether it is concave or convex. All right, let's look at this first one. Okay, we can see that, first off, that it has 4 of the same sides. That's good. Okay, but you'll notice we have 2 different types of angles. Okay, we have that type and we have this type. So because we have 2 different types of angles, you know that it's going to be irregular. Okay, so this is an irregular polygon. And because we don't have any parts that cave in, this is going to be convex. Okay, so an irregular convex polygon is your classification on this one. Okay, so this guy, he has different side lengths, so you know that he is also going to be irregular. Okay, and it has parts that cave in, such as these parts, so this is going to be concave. Okay, one more example. This guy has the same side lengths, and he has the same angles all the way around, so he is going to be a regular polygon. And he doesn't cave in at all, so he's going to be convex. Okay, so make sure you're aware of those terms, you're able to classify what type of polygon it is, and that should be good enough. All right, I'd like you to try, number 1, or you try 2A, and you try 2B, and that will be the end of our section. Next time, we will move on to section 1, part 2.